Hello everyone and welcome to another episode of Data. So today we are going to begin a new series about which is about a soft guide to language models from basic models to the large ones. So this is not going to be extra deep dive into what a language model is or the criticality of it, but it's going to be a very light introduction about what a language model usually is, how it works, and then we are gradually going to uh, explore what the large language models are. So things that we are going to learn in this video. So basically, what is a language model? We are going to understand what the basic internal structure is of a language model. We are also going to explore certain terms like encoders and decoders, and what is the purpose of encoders and decoders basically. So let us take a very high level look on this so-called language models. To begin with, a language model can be considered as a black box, which given an input gives you an output. So say for example we want to translate a certain text from English to Hindi, and we give that to our language model, and it gives us back a prediction, basically the translated text to us. Now that we know what a language model is from a very high level, let us jump down a bit lower and zoom in a bit more into the exact structure of this kind of models. So for the sake of simplicity, we can consider a language model to be made up of two things. One is the encoder, which is highlighted in the blue box, and a decoder, which is represented by the green box over here. These two things together give or impart certain functionality to our language model. Zooming a bit more into the encoder, we know that the encoders are further made up of tiny blocks, or as we call in the context of deep learning as the layers of a neural network, because encoders and decoders themselves are neural network and they are made up of certain layers which can be considered as blocks of jigsaw puzzle which can fit together to perform certain tasks. So the structure of encoder and decoder are exactly the same. The functionality may vary. Now, neural networks don't exactly understand text, right? They don't understand words. What they understand or what they are good at understanding are numbers. So, an encoder takes in a text and converts that into a stream of numbers. So, each word has a numerical representation once it passes through the encoder. Decoder do the exact opposite. They feed on a stream of numbers and then give you back a prediction, for example, a translated text. Now encoders don't take in the exact text that we give them, but they actually take uh, chunks of text such that the input text is converted into chunks of words, and this chunking is known as tokenization. Now the words pass through different layers of the encoder, and they get converted into stream of numbers, which are otherwise known as vectors of numbers. And while this conversion is done, each word from the input text is mapped to the other word, or in short, the numerical representation of each word in an input text is mapped to the numerical representation of the other word or the word surrounding it. And why it is necessary, we'll get to know in the next slide. So as I said that each word's numerical representation is kind of mapped to the numerical representation of the other word. So this is necessary to maintain a context or to help the neural network understand the context of different words in an input text. So say for example, this is a text, I saw a cat, it jumped over the fence. Now in this text, the word it relates to cat and not the fence. You and me, as humans, we know that it is simple for us to understand, but it is not that simple for a neural network to understand that the word it actually represents the cat and not the fence. And to make the neural network understand this context, whenever a particular word is converted into a stream of numbers, then the encoder kind of takes in the context of different words before it and after it into its own set of vectors. So the numerical representation of the cat has the context of the word ate, the word saw, the word jumped, and everything in it. So whenever the neural network sees the vector representing the word cat, it knows that the word after that, that is, for example, it here, relates to the cat and not to some other. Now a decoder undergoes training. Actually, the entire language model undergoes training, both the encoder and decoder. And the decoder has a numerical representation of different input text, that is the training data it has. So it can be considered as a knowledge base for the decoder, which are just numbers, but they are representation of different kind of words that it was fed during the training period. Now, when during the prediction part or the inference part, if you did a sequence of text, for example, and ask it to complete the text for us, that is, to predict the next word in a sequence, it takes that sequence of words which we have fed it during the inference and then compares it to the numerical representation or the knowledge base that it had from its training time, and kind of tries to see the context of the input text uh, with the context of all the numerical representation that it had during training, and then comes up with a prediction of the next word in the sequence. So this was all about what a language model is. I mean, it is a very basic introduction, but I will leave links to certain beautiful articles in the description sections, which you can refer to understand or to deep dive into how exactly these encoders and decoders work. Now the exact calculations appearing inside an encoder and decoder is out of scope for this video, but you can go to the description section, get to the links that I provided, and then get a good idea about or in-depth idea about how the mathematics actually works. So this is not all. We will come back to explore some more things or to go a bit deeper into the language models, as I said, and then we gradually move on to the large language models. So do like, share, and subscribe. So this way you will get notified about the next video that I am uploading whenever I am uploading that, which I will be uploading soon enough. And you liking my video and sharing it makes others makes it easier for others to discover my content. Thank you.